Chapter 4.1 is on the introduction to linear systems. A linear system of equations or inequalities is a set of open sentences containing the same variables, and a sentence is like an equation. So an example of a linear system would be this: 2x minus y equals 10 and x plus 3y equals negative 9. And so you have your two sentences, and they both have the x and y variables. And the equations are called simultaneous equations, namely the equations inside of a system. So when you are given a system of equations, the solution set is the set of ordered pairs that satisfies all the equations in the system. So the x and y coordinate will have to be true for both equations or all three equations. And your solution is expressed as an ordered pair. Chapter 4.2 is on actually solving the solutions of systems of linear equations. So if we look at our same example, you have 2x minus y equals negative 10 and x plus 3y equals negative 9. And so in order to solve this system, you need to make the coefficients of one variable either equal to each other or opposite, so that you can either add or subtract the two equations and eliminate that one variable. So in this case, we are going to multiply this top equation by 3. So both sides, we have to multiply the whole equation because it stays the same, then will be multiplied by 3. And then we can rewrite this as 6x minus 3y equals 30. And then what you can do is you add the two equations. So you have 6 plus 6x, so 7x. 3y minus 3y is 0, so you don't have to write that. And then negative 9 plus 30 is 21. So you have 7x equals 21. So you then divide each side by 7 to get x equals 3. And that's one answer. And then what you do is you take the x minus 3 and you plug it in to one of the equations. So let's plug it into the second one. So you have x plus 3y equals negative 9. So 3 plus 3y equals negative 9. And then you solve for y. So 3y equals negative 12. Y equals negative 4. And that's your y answer. So then the answer to the system of equations is 3, negative 4. And that is how you solve linear systems. So let's practice again. So 3x plus 4y equals 6. 5x minus 7y equals 14. So the easiest one would be to get rid of x's because they have a common number that's pretty easy, namely 15. So you want to multiply the first equation by 5 and the second equation by 3. So if you multiply by 5, you'll get 15x plus 20y equals 30. And the second equation, you'll get 15x minus 21y equals 42. And then because the x coefficients are the same, you want to subtract the second equation. So 15x minus 15x is 0. 20y minus negative 21y is 41y. And 30 minus 42 is negative 12. Negative 12. So you divide by 41 and you get y equals negative 0.2926. So we can then plug in the y value, which if you remember was negative 0.2926, and we can plug that into this y value right there. So 5x minus 7, negative 0.29 equals 14. So 5x plus 2.048 2 equals 14. 5x equals 11.95. X equals 2.3902. So we can express our answer as an ordered pair. So 2.39 negative 0.29. And that is the answer. So the method which we've been using to solve these linear systems is called the linear combination method, which is also known as the addition and subtraction method because you add and subtract the two equations. Another method that you can use is called the substitution method. And what you do in the substitution method is you solve one equation for x in terms of y, or vice versa, y in terms of x, and substitute the result into the other equation. So what this looks like is if we have the system of equations x plus 2y equals 2, 5 minus 3y equals negative 29. If we solve this first equation for x, so we say, so you move the 2y over, so x equals negative 2y plus 2. And you can plug in this for that x right there. So 5 negative 2y plus 2 minus 3y equals negative 29. And then you solve for y. So negative 10y plus 10 minus 3y equals negative 29. So 10 minus 13y equals negative 29. Negative 13y equals negative 39. Y equals 3. And you can plug in the y value back into the original equation. So we then have the y answer of y equals 3, and we can plug that into this equation. So x plus 2 times 3 equals 2. So x plus 6 equals 2. X equals negative 4. And then we can write our answer as an ordered pair, negative 4, 3. And that's just a different method of doing the same thing to get the same answer. And the third method is what's called the graphing method. In the graphing method, you plot the points, you plot points for each equation, and then you find where the points intersect. So if we look at these two equations, we want to change them. If we rewrite them in slope-intercept form, this first one looks like y equals negative 2/3 x minus 4, and the second one is y equals 8/5 x minus 8. And if we plot these two equations, they look like that. And then if we find the intersection point, it is right where they intersect, so right there. And that point is 1.765 negative 5.176. And that is a lot easier if you have a calculator to go with it. You can plug in the two equations into the y equals menu, graph them, and then find the intersection, and it gives you the point. So that's a lot less mathematical skills that you need, but you can only do it if you have an acceptable calculator. So far, all of the examples of our linear systems have been independent equations, which are where the graphs intersect at exactly one point. But if you consider the system of equations of 5x plus 3y equals 15 and 5x plus 3y equals 25, if you subtract the second equation, you get 0 equals negative 10, which is not true. It's false. So this system is considered an inconsistent. And an inconsistent system means that there are no common solutions. And this only occurs when the lines are parallel, which would occur if you changed these two equations into slope-intercept form. They would have the same slope. And so these lines never intersect, so there are no solutions. Now if we look at the system of equations of 3x plus 5y equals 10 and 3x plus 5y equals 10, it's the same line. And so this is what's called a dependent system, where there are an infinite amount of solutions because it's the same graph. So every value of x for the first one will have the same value of x for the second one, and the y values will be the same. And so there's infinite solutions. And so that's the three different types you have your independent equations, your inconsistent equations, and your dependent equations. So let's practice. So we're given the system of equations of 14x plus 31y equals negative 6, 21x plus 17y equals 15. So we want to mess with the x values for this one. So if we multiply the first equation by 3 and the second equation by negative 2, it'll yield a 42x plus 93y equals negative 18. And the second one will be negative 42x minus 34y equals negative 100. And we're going to add them. So you get 0x plus 59y equals negative 118. If you divide by 59, you get y equals negative 2. And we plug that into our y value for the first equation. Doesn't matter which one, but let's just do the first. So 14x plus 31 times negative 2 equals negative 6. 14x minus 62 equals negative 6. 14x equals 56. And then x equals 4. So we have our ordered pair of 4, negative 2. And that's our answer.